Okay. Hi, every member of the Global Innovation Field Trip. My name is Hefsiba Petro. I am a student at the Vocational Education Training Authority College. I live in the Kigoma region of Tanzania. When I am done with my school, I would like to engage in electronics activities such as automation systems and communication systems. I would like to be innovative and creative in designing different electronic devices that help us solve different challenges in our everyday lives. Okay, here he is. I am a student at the Technical College in Tanzania, and the project is called Rectifier Trainer. Okay, Rectifier Trainer.
The main purpose of this project is to help the students who are learning in electronics to determine and understand different properties of components such as diode, capacitor, transformer, and other and so on. So now this rectifier has made of few things that can help the student to learn easily. For example, here we have the transformer. Also, we have the diode and the capacitor and the zener diode. That components have connected in form of power supply. This connection help to get.
Okay, he's going to go on. Okay, so let me just mention, he's mentioning a lot of electronic components. These are all solid state, state-of-the-art components. He's really at the cutting edge of what is going on, and he is building a device to help students learn, to train them. Okay, because many circuits are complex, I picked the part of the power supply coming from the transformer that filters the current so that if it was used as a teaching model, it will be easy for the students who are studying electronics to understand. This device uses the concept of bridge rectifiers in electronics for changing the alternating current to direct current. Its operation is that when the step-down current from the transformer enters the 4 connected bridge diodes, the result is technically DC, but with a large amount of ripple. The rippled current is then filtered by shunt capacitors to obtain a very smooth, pure DC. Now, for those of you who understand what he's talking about, you know that he is correct, okay? For those of you who do not understand some of this electrical engineering jargon, let me assure you, he is correct, okay? And I just want to show you the circuit, and he's drawn this, by the way. I'm not good at that. So he has a AC alternating current. Our electricity from our wall does this, it goes back and forth. Oh, there it is, okay? And it's probably at a higher voltage, 110 volts in the United States, probably 220 or 240 in other countries. And they have a transformer that brings it down to a lower voltage. It's a little bit safer. Then the rectifier straightens it out. Instead of going back and forth, it only goes in one direction. And then you have a filter, which smooths it out, and then you maintain a proper voltage. This is what happens to all of our electronic devices. We plug stuff into the wall, and that electricity in the wall is too dangerous for us and much too dangerous for our devices. There needs to be a circuit that protects everything. And here is his circuit. And this is the transformer. This is the rectifier that will change all of that to DC, direct current. And then here is the capacitor and the other parts that will smooth it out. So let me just show you a picture. This, by the way, is his picture. Okay, I just get to take credit for everything. This top is AC, and the electricity is going back and forth and back and forth and back and forth, okay? And when you rectify it through this part here, you end up with this. Now, technically, this is DC. It's only going in one direction, but it's got a lot of ripple. It's got bumps. It's not very smooth. Our appliances will not work with this. So then we go through the next phase, and this is where, with the capacitor and the other components, it smooths it out. And now you can see the ripple, the amount of back and forth, not back and forth, but up and down is a lot smaller. And this is now usable. So here is his actual device. This is the transformer right here. These are the diodes. That was part of the diode system we had. Here is your capacitor. Okay, so he's got all these components. And here he is, and he's showing it's working a light. And let's hear from the master himself.
So now let's gonna see how this circuit works. When you trigger on the wall switch, there is a LED diode that show that your circuit is on. That LED diode indicate that it can be used. So now if we want to use it now, you can trigger on to another switch that is showed by the green diode that there is already DC output that comes out. So now we see that there is a diode that emit light. The diode that emit light, it is have the positive and the negative terminal. So this uses DC from AC current. That when we look to our circuit, the rectifier that was made have used the bridge rectifier. So now the student can be instructed by his teachers or instructor that the current enters the transformer should be stepped down to this transformer and then enters to the diode. There where the diode will get the amount of DC that have some ripples of AC. That ripples discharged the shunt capacitor. That shunt capacitor will be give out the pure DC and some content of amount of AC. So now we're given out to the diode as a regulator. The diode as a regulator give the amount of DC that are limited to the user of the current. So now when we trigger on the wall circuit, we obtain that there is a LED diode to our circuit that have given a LED light that indicates that our circuit is on. So now when we want to use it, we trigger on the switch. So we see that there is a green diode that gives it right to indicate that there is the output DC. So now output DC have come to be used by the lighting emitting diode that gives it right. So now this show that DC current can be obtained from AC current. That a student can be taught by showing practically and help him.
So, therefore, through this teaching, the student can understand how easily it is to produce DC current from AC. It is better to teach by practical activities than just by theory.
Everyone remember Global Innovation Trip. My name is Hefsiba Petro. I am a student in a vocational education training authority in Tanzania. Also, I'm living in Tanzania in Kigoma region. When I have done with my school, I would like to engage in electronics activities such as in automation system and the communication system. Also, I would like to be one and the innovative and the creativities in different electronics devices that help us to solve different challenges that are facing our daily lives. Well, until there, thank you.
Okay, I just have to tell you, as an engineer and as a teacher, I am very, very happy to see this. Here is a student who has learned, and he has taken his learning to try and help other students to learn. And I think that is wonderful. The other thing that I loved about this, if you looked and saw his materials, he was mounting things on cardboard, and he had hand wires and twisting things together. this is all state-of-the-art electronics, but you do not need to spend enormous amounts of money to learn state-of-the-art. Maybe if you're trying to launch a rocket to the moon, you take millions of dollars. But to do electrical engineering, you need cardboard, a few simple components, and the will to learn. So I'm very, very proud of him, and very excited that the other students will see this and go, oh, wait a minute, I can do this too. Rohan.
So in those 5 steps, so he converted the AC into DC, right?
Yes.
Yeah. So that line, what was it? Or what was it?
The
What did
line.
it represent? Like that went up and down, that changed.
Okay.
Like
Yes. Let me just see if I can share the screen again. Okay. You're seeing the screen?
yeah.
Okay.
So it got straighter and straighter as it went.
So let me explain what's happening. Electricity is generally created in something called a generator, and the generator spins around. There's some wires inside that spins, and if you look at my finger, you see now as I'm spinning, I'm going in one direction, right? But now look, I'm going in the other direction. You see that? So I start, and I don't want to use left and right because I think everything's reversed, but I'm starting to go up. I'm this way. I'm going this way. Here I am. I'm going this way. This way. I'm going this way. And now I'm going the other way. I can't do it. I'm getting confused. Okay.
Changing,
Anyway,
like
what that means is the electricity goes one way and then it comes back, and then it goes one way and it comes back, and that's what it's doing in your walls. The electricity in your walls is alternating current, and the reason it's alternating current is because it turns out that that's a lot easier to make. It is a lot easier to make electricity that goes back and forth. Okay, and this was a huge fight between Thomas Edison and Nikola Tesla. Edison believed in DC electricity that only went one direction. And the reason he believed in that is because that's the kind of electricity that batteries create. A battery has a positive side and a negative side. Electricity only flows one way. And
when you put it in, it has that like plus and minus symbol.
Yes,
and you put it
yeah. And Tesla was an electrical genius, and he created devices, generators, which were very cheap to make and very, very efficient, but they made electricity that went back and forth. And so there was a huge fight between Edison and Tesla, and it turns out Tesla won. And so
now we usually use like the back and forth.
Yeah, we use the back and forth. Now, that was wonderful in the 1920s, the 1930s, the 1940s, and even the 1950s. That was wonderful. Then we came to the 1960s, and all of a sudden, people started making solid state devices, the things that we saw in this other video. And solid state devices work best with electricity that works in one direction, DC. So now the problem was, oh my God, we've made a real easy way of creating electricity and sending it, but now we have to convert it from AC to DC. So when you have a power supply in your computer or outside, what that is doing, it is taking the high voltage AC and turning it into low voltage DC. And that's what's happening in your computer. A lot of computer products work on 12 volts, 5 volts, sometimes even 3.3 volts. So they have brought it way down. And that's what this diagram is. That's what this is all about. So this is AC. This is technically DC, but if you tried to run, for example, if you tried to run a motor with this, it would go,
ripple.
It's on, it's off, it's on, it's off, it's on, it's off. It would drive you crazy. So anyway.
So the ripple will be on always, right?
Yes, you want it on all the time. When you turn on the hard drive on your computer, you don't want it to be starting and stopping. You want it to keep running, right?
And you like when you use a generator, like for when like the power goes out, or like, do you use that way when it goes up and down? Or
No, no, this is
or
this
back
is
and forth?
this is an interim way. Nobody uses this. This is bad.
That's just converting it to,
Yeah,
right?
yeah, this is just a step. But here's the point. That's the plan. Rohan, you can get these parts, okay? A transformer you can buy for $2, okay? These diodes cost 50 cents. The capacitor might be another 25 cents. This whole thing is under $2, $3. So it's certainly something you can work with. And Rohan, one more part. This part is dangerous. Right here, this is the high voltage AC.
Oh
That's
yeah, you don't touch that because
yeah,
that
don't touch that. But everything after this is perfectly safe. All this stuff over here is perfectly safe. The worst that'll happen is it won't work, but you're not going to get hurt. So this is where I work down here. It's safe. Okay,